Hey guys, thank you for joining us for today's EMQ's Office Hour session. My name is Keen Chen. I work for EMQ's marketing team. So very quickly, I want to first just walk you guys what we have for experts today and what we have for agenda. So first off, we have three EMQ experts today with us. First is Brandon Ruiz. He is product marketing manager at EMQ. He has decade of product marketing experience with SaaS and B2B companies. And second, we have Ivan Dyachkov. He is development manager at EMQ. He has 2 decades of experience in managing engineering teams for different IT companies and startups. And then we have Jun Gu. He is director of community engagement at EMQ. He has decades of experience in database management and data software. And then for agenda-wise, we have two presentations, and then we'll open up the floor for Q&A. So first, we will have Brandon walk us through smart manufacturing and how to use MQTT in smart manufacturing. And secondly, Ivan will give us our latest product updates on EMQ Enterprise 5.8, which we just launched last month in August. So he will walk us through the new features such as cluster linkings, message transformation, and other features. And then we'll open up the mic for Q&A. Just a couple of quick housekeeping notes before we start today's presentation session. So first, you can feel free to submit your question anytime during the session in the Q&A tab. You should see it down below in your Zoom bar. Or look at the question anytime, so you don't need to wait all the way till the end. We'll answer the question at the Q&A session, but you can submit your question anytime. And then also we'll launch a poll during the session, so we'll greatly appreciate if you can fill out a poll. It'll help us improve the session. And lastly, the best way to contact us is through our Contact Us page. That way we'll know what's your specific needs and then find you the right experts. So with all that being said, I will hand the floor to Brandon and he will walk you through MQTT and how to use that in smart manufacturing. All yours, Brandon.
Great. Thank you, Keen. Good morning, evening, afternoon, everyone. Thank you for joining our session. Really appreciate having you here. We realize that there's a lot of options for content material for you to tune into and learn. So we really do appreciate and recognize that and hope to give you kind of a good crash course on this topic and open it up to discussions and field some live questions at the end here. So today, I will be introducing and speaking to the concept and idea of unlocking the value in manufacturing by way of IoT. So, Keen, next slide, please. So, want to start off here with the challenges in implementing IoT solutions, right? And kind of what the need or the draw is for this evolution, for this progression into Industry 4.0, right? And there's four that really stand out. These aren't by any means the only kind of driving forces behind this. But one of the challenges that we see in manufacturing is interoperability or interoperation between different device types, whether it's a robotic arm, assembly line, a paint shop, right? Depending on what your manufacturing process is. And then on every single one of those different devices, it's equipped with different sensors, right? That speak different languages or different protocols. So in your manufacturing floor, how do you pull together all those different instances and devices and of different ages, right? So you can have brownfield devices that have been deployed for 20 years because they have long life cycles with net new devices that were just put out there along these other devices. How do you pull it all together? So that's really a big challenge that we see. Number one. Second one is data siloing. So across these different work sites, right? There's different areas, different lines, and just overall different arms of business. And every single one of those categories that I just listed off has its own way of kind of siloing that information for that particular function, right? More often than not, it will have its own access point, its own dashboard that you go into with a very limited view of what's kind of happening across the organization, right? If you wanted to be able to react quickly and base your decision off of multiple data points, right now, for a lot of folks, it's going to require you to kind of send inquiries to different teams, share your dashboard and data points, right? So it's very much manual and it's a laborious process. So organizations need that speed and agility to be able to have a broader view of the business, to be able to make more of those data-driven and real-time decisions. And today, the way it's architected makes that very difficult. Scaling. It's another pain point that we see there, pretty common across a lot of manufacturers, and we are pretty active in the space. So a lot of this is based off of those conversations and our dealings with our customers today. As I mentioned, a lot of these manufacturers are multi-site, multi-region, and share different manufacturing processes, right? So once you get things to work, how do you do it in a way where you're scaling without interruption, without degradation to your performance, right? And make sure that the ship keeps running at an optimal pace. So something that you can also address by kind of leaning into Industry 4.0 and the whole concept of digital transformation. And then last is costs, right? So as you're connecting all of these different devices, and today, a lot of these devices are connected concurrently, right? So they have a constant push-pull relationship, which, as you can imagine, at a large scale with all of those devices that I mentioned per site, per line, per area, your cloud compute and storage costs are going through the roof, right? So how do you get in front of that? How do you get ahead of the curve and still get those benefits you want, but in a more efficient and effective way? So next slide, please, Keen. So that's where I want to give the introduction to MQTT. So for those of you that are not familiar with EMQX, this is our bread and butter, right? We are the most robust and scalable MQTT broker out there. And the reason why this is seen as a solution for the space to address those pain points that I mentioned, right? This protocol has been around since the 90s, right? It was founded by Andy Stanford Clark and Arlen Nipper, who were part of the IBM team back then. And the reason why they created this was originally to be deployed in oil SCADA systems in the oil and gas industry. So they needed a reliable protocol that was able to perform in basically harsh conditions, areas where you would imagine connectivity is hard to come by, right? So that's either rural areas, right, in agricultural territories out in the middle of the field somewhere, or in highly congested areas like a city, smart cities, or manufacturing plants where there's a lot of different signals and communications going around, right, in very dense areas. And then the third one, which is not as tied to this, right, is for mobile or transient instances, right? So in the automotive space, which is another big sector for us. So in areas where you have network switching in your vehicle, this is another area where MQTT really shines. One thing that makes it a great too is that earlier I mentioned that a lot of devices are using concurrent connections. MQTT in its nature, it decouples that constant connection and it only connects when it needs to share and transmit status changes, right? So you can set those rules. So that will help you with some of the problems we talked about earlier. It is very reliable. So there are three means to be able to check this quality of service. There's 0, 1, and 2. Essentially, what this is going to do is just ensure that the message gets from point A to point B, right? And there's different logic and different kind of outputs that you can get at different stages there, right? So most folks use QoS 1. That really, I think, in a lot of scenarios, checks the box for a lot of folks. QoS 2 have found that given the nature of it, it can sometimes cost a little bit more. But if you, in instances where you have high criticality, it is a good option to make sure that it's only delivered once. You don't have duplicates going across. And also the size of to be able to deploy this, right? It can go as small as 2 bytes all the way to 250 megs. So your range for messages can be incredibly small and a pretty sizable payload, right? So, and the nature of it too, it really pulls down that bandwidth I mentioned for the decoupling. So let's go ahead and go next slide, please, Keen. So that brings me to under the lens of MQTT, right? The evolution of ISA. And if you're in the manufacturing space, this pyramid is going to be very familiar to you. This is essentially kind of Industry 3.0, how things are architected today, kind of stack ranking, operational technologies, information technologies. And although, this is effective and a lot of folks have been using it, the fact that it's point to point is very limiting, and it takes a lot of time to pass information from bottom to top, right? And back and forth rather. And at the side there, you can go ahead and see incremental jumps in time that's added as you go through each step, right? So starting from milliseconds at the bottom there, seconds, minutes, hours, days, and months, right? From top to bottom. And that is by no means it's not enough time for you to act on anything before actual failures occur. So you can bet that you will run into downtime and you won't be able to make agile decisions to marry these two different groups of technologies, right? So that really drew a need, and that Industry 3.0 came around, 60s and 70s, when logic controllers first came out. So the natural progression there is how do you go away from this stacked point-to-point architecture, right? And that's where the introduction of Industry 4.0 came about. So instead of stack ranking it like this, we're now looking to connect all of those points. They're still point to point, but now it's not just up and down. You can go left, right, bi-directional, right, to different devices. But this in itself has its own problems too, right? You still have a lot of dependencies, a lot of points of failure. So let's say you wanted to update your CRM or you wanted to update your MES system, right? Given all of those connections and those dependencies, anytime you pull those out to make updates, you will run into some drop-offs in performance or downtime. So how do you further progress this model of Industry 4.0 to kind of bypass that problem and be able to provide you things like redundancies, where you don't have so many dependencies across every single point? How do you minimize that, right? So that's what brings us to the next concept. Next slide, please, King. The concept of unified namespace. So as I mentioned, cutting through the noise of having all of those different connections across to each other, it's the unification into a unified namespace. So all of these different areas that I mentioned are now being connected to that central control point, right? And within that unified namespace, what sits in that middle GUI area is going to be MQTT broker like EMQX, as well as a visualization platform like a Grafana or a Snowflake, Datadog, Prometheus, and many others, right? So now, if you want to be able to update your CRM, you can do so without interrupting the rest of the business. And that's the pain point that folks are having is how do you go from left to right here, right? How do you build that framework to kind of detangle these connection points and set up this more seamless architecture? And that's really what the industry is looking to now, right? A lot of folks are asking, what's my preparedness for this, right? And what do I need to do digital transformation if I haven't already started? I have all of these existing systems. If I want to adopt this, do I need to cut ties and kind of restart? And the simple answer there is no, right? But just know that whatever we cover today, it's not going to be a perfect form fit for everyone, right? Every manufacturing floor is going to have kind of different variables in play. So it will require some level of consultation to be able to see what's operating there, to be able to give you your solution to make this as custom and most efficient for you. Next slide, please. So with unified namespace, it really is going to pull together your edge devices and the cloud, right? Pulling through that central unified namespace that I mentioned. And the whole point and value prop behind this, right? It's really addressing those challenges and pain points that we went through at the start of the call, right? So by having this central point, you're going to knock down those barriers for those data silos. And no longer will you have to go to, 15 different people, 15 different dashboards, gather these data points, try and massage them and weave them together. No. Now you'll have one dashboard you can log into that will give you visibility across the entire business. And don't worry, don't fret. There are mechanisms in place like role-based access control, right? Where even though you do have visibility across the business, you can limit and set those boundaries so the right people have control of certain aspects, right? So that is something that's really important and will help people become more agile. And ultimately, by having that broader view and having that real-time data collection, it'll allow you to make those more informed, data-driven decisions. And what I mean by that is instead of waiting and kind of being reactive to failures, because you're getting this data in real time, you'll be able to detect imminent failures and trends proactively. So now you can go ahead and set kind of repair or maintenance schedules ahead of time and try and do contingency plans to make sure that you can swap things out seamlessly, have redundancies running so it doesn't pause your business. And the other one is optimizing efficiency and productivity. And this one was interesting. Started to hear a different kind of tone on this topic. Was once upon a time, and it's still around today, and people are still interested in it. But it seems like folks are less interested now in things like predictive maintenance and downtime as much. Like again, it's still a big topic, right? But now folks are more interested in seeing how we can leverage these technologies to optimize existing processes to maximize output and make their systems run even better, right? It sounds like a lot of folks do have mechanisms combined with AI to help them with the uh, degradation and downtime. So just an interesting take I wanted to share there. But again, you're able to achieve both with this technology and be able to just streamline your overall operation. And I guess the last part I want to pull in here for this slide is this is not something that is a maybe. This is definitely something that is being leaned into heavily. Folks are investing big dollars in this technology. And what we want to say is it probably is in companies' best interest to kind of start adopting these technologies for the mere fact that you do want to stay competitive and you don't want to be left behind to your other competitors in the field, right? And the example I like to point to and speak to on this one was when Industry 3.0 came around, right? As I mentioned in the 60s and 70s, not everyone, including the United States, was really on board with adopting logic controllers. Countries overseas did, and I would say as a result, they were able to grab the reins and lead the charge for 10 to 15 years. So rather than having history repeat itself, right? Jump in with both feet, trust in a strong partner that can get you through this and get you set up so you can go ahead and keep chugging along there. Next slide, please. So one of the great things about pulling in MQTT into this concept of unified namespace is organizing and managing your hierarchy of information, right? So on the left there is an example of how this would look in a unified namespace for you to drill into. Kind of going from the top down, right? We did kind of touch on these a little bit, but there's different ways you can drill in. It can be by work site, by individual area, by line, by device, by sensor, right? You can go very granular with this. So the whole concept and I should mention this too, unified namespace is something, a concept that has been around for quite some time, right? Uh, Recently, last few years, the actual term unified namespace was coined by a man named Walker Reynolds, who is part of a company now, Industry 4.0 Solutions, and it is something that is, I think that's the name that's being used and most familiarized today. And one thing I do want to mention here that we're proud of is Walker in his own materials did share that in 80% of their deployments where they're helping consult and get folks deployed with UNS, they are using EMQ as, because very performant, very easy to dabble with. So thought that was a good little data point wanted to share with the group here. But so you have your drillability, and then now if you want to shift over to MQTT, given the nature of it and being able to search by topics, you can see an example of how that would look in the system, right? So below the diagram there, showing namespace slash group slash message edge node, you have your hierarchy, and then you have your by topic filtering as well, right? So when you marry the two, that's what really makes MQTT kind of the de facto solution for implementing unified namespace. Next slide, please. This is another important one too. So event-driven architecture. I know I did quickly introduce this earlier, but in a manufacturing floor, right? Whether it is a robotic arm that's applying pressure, a certain line that is doing a heat press for temperature, right? When you do that at scale, having that constant push and pull connection between your device and the cloud or edge gateways to the cloud, it's going to create huge overhead, a lot of compute power for storage. So you're really going to be paying through the teeth on these cloud fees, right? So how do you work around that? So given, I guess, two things. Given the decoupling nature of MQTT as a whole, right? You can go ahead and set up your system where it only reports by exception. And what that means is instead of your robotic arm transmitting and processing a data point that says, I'm applying 50 pounds of pressure every second, right? So you have that same data point repeating over and over and over again, you know, for weeks, days, months, right? You're now only going to transmit a data point out when it goes from 50 pounds to 50, 55, or 60, or even lower, right? Just a state change. So that's the reporting by exception, and that will help you cut through those large cloud fees that you'll be seeing otherwise. And some other features that help you with that too, to ensure, we get a lot of questions around how do I know if my device goes offline? I can't afford to have it offline and not have any knowledge of it, right? So there's two mechanisms through MQTT that besides quality of service, that's one big one. There's a last will feature. So similar to wills in our personal lives, right? Planning for unexpected and sudden events, you're able to kind of set a rule that, in the event of this happening, we need you to notify this person, we need you to shut down this line, we need to jump over function to another node, right? You're able to set those rules and conditions to prepare for such an incident. So that way, if those things do pop up, you're prepared, you have a contingency plan in place, and there won't be any surprises there. Related to last will, there also is another feature within MQTT called Keep Alive. So what that check is it's you can set a time frame, right, that you want the system to do a wellness check. So that cadence could be, it could be 10 seconds, it could be 5 minutes, could be a week, and you get the picture, right? But what that is you're basically setting a rule that your system is regularly checking to make sure that it's running optimally and that there's no issues, right? So even ahead of last will, before something goes offline, you're having these proactive wellness checks along the way to make sure that everything is going as it should. Next slide, please. So here is an example of the architecture from edge all the way to cloud, especially working with EMQX. So you'll have the connectivity, and the way that we're able to cut through that, and the next slide does have another view of that. But for the connectivity piece, the way that we're able to pull together and unify these different devices is through an edge gateway that we call Neuron EX, and that is a we're strictly a software company, but that's the one, I guess, hardware component you can argue that we offer. That we would work with you, and you would have to deploy it on something like a Raspberry Pi, or it could even be on the floor if your devices have enough headroom. But this solution that is deployed amongst your devices in the field, it's going to ingest the different protocols and communications from all of your devices, right? So Neuron EX today has support for just north of 100 different um, industrial protocols. So what it does is it will take in all of those different communication standards, and it will unify them and convert them into MQTT, pass them to the broker, which from there you can go ahead and run it through a rules engine, where you can program more logic on where you want your information to go and in what form factor. And then from there, you're able to run it through streaming services like Kafka, Confluent. You can run it into different databases, AI services, and or even into management and monitoring platforms that I mentioned earlier, like Grafana, Snowflake, Datadog. We support all of the key ones there that do garner the most interest. And it's important to note that from a deployment option standpoint, very flexible, right? So given the different privacy and security concerns, you can go ahead and do it on premise. You can do a public deployment, private cloud. You can even container it and do it in Docker or Kubernetes. So huge amount of flexibility there. And since we did talk about kind of backend plugins, it is important to note that we do support north of 40 different native integrations today. And the value there is that, when you go ahead and get started, if you do have a lot of these systems in place already, what you're not going to have to do is now figure out how to custom code that all together, right? Because we have these native plugins, that process to get all of your things connected is much more seamless. Next slide, please. So this is just an example of a steel factory production. So if you look closely there, you can see that Neuron EX, which I mentioned in the previous slide, is that in between, that edge gateway that is ingesting data from all of those different device types and lines to the left there. And it can either do a direct pass through to other third-party systems on site, or you can go ahead and run it through our broker to be able to get to those other backend cloud systems that I mentioned, right? So databases, streaming services, if you have an AI tool that's in place today, we can funnel into that too. So a lot of optionality there. And this is just, again, one example, but every deployment's different, different devices, different areas, different regions rather, right? All of which are things that we can support and be able to identify and working together. So the big picture in this whole topic, right, of technologies, unified namespace, and just IoT, right, is working from edge to cloud. So again, introducing Neuron EX, it's going to be that edge translator that's going to pull together all of your devices. And then another topic that we hear quite a bit is, oh, if I adopt this and I have Sparkplug or OPC UA, do I have to abandon those, right? And in a lot of perspectives out there, oftentimes is yes, right? That you would have to. But we have a lot of material and we have a lot of proof points to show that you can actually marry these technologies with MQTT. So added an extra T there, sorry. Where you're using the transmission capabilities of MQTT and the data kind of configuration and modeling from things like OPC UA. So you pull those together and you have a more even more seamless solution there. So don't worry about that if you have that in place. That is how you can kind of pull those two together. And ultimately, in doing this, you're being able to unlock that efficient messaging and data routing from across your entire business. So you'll have visibility, you'll be unifying your devices for interoperation, and you'll be able to do things like predictive maintenance. You'll be able to optimize your devices, and be able to, once you get this deployed and get one area working, in most instances, if you're deploying other work sites with similar things, you can do cookie cutter and quickly get those things ramped up where the first deployment may have been a little bit slower. And I believe that's all I have. So with that, I would like to hand it over to Ivan to walk through some of our latest product updates as well as what's coming down the pipe.
Thanks, Brandon. Yeah, let's go ahead. So MQX 580 was released last week of August. Quite a few interesting features. First is cluster linking, and like if you are proficient user of MQX or MQTT in general, you should know that it's possible to configure MQTT bridge, like make your broker to send certain messages from certain topics to another brokers. So they question like, well, what is cluster linking? But what it does, it's a little bit more smart than the regular bridge. It will not use any traffic if there are no subscribers on topic. So for example, if cluster A is linked to cluster B, and in cluster B there is no subscribers to linked topics, then there is no traffic. Next is message transformation. Again, it's another way to make it easier to transform and enrich messages by using simple syntax. So you don't have to write SQL in a rule engine, and so it's a bit more convenient. Rule engine itself, you should be able to now use client attributes, which we introduced in previous release. You can use them in rule engine to enrich your messages. And there are a couple of new SQL functions. One of them is to simplify handling null values in SQL expressions. For authentication authorization, we now support OEDC SSO protocol. Cerberus MQTT client can use Cerberus authentication. We support ACL rules in HTTP authentication response. For example, if you have an HTTP service which handles your authentication, you can return ACL rules as well from that response now. Improved HTTP authentication in general, and they introduced enhanced GWT authentication. Yeah, the next slide. New data integrations. It's Azure Blob Storage, Couchbase, data layers. It's a time series database, and an option to configure static Kafka consumer group ID, which is important with some cloud providers. Unfortunately, we had to introduce some breaking changes for Community Edition. So it will not be able to add replica nodes in Community Edition. From now on, it will be enterprise only feature. And some features have been removed from dashboard, flow designer, some authentication methods, and a few more. And unfortunately, you can use durable storage in Community Edition, but only with a cluster. So you can run a single MQX node with durable storage enabled, or a cluster of core nodes without durable storage. Yes, and for MQX 5.9, preliminary roadmap looks like this. We're going to introduce message queue and durable shared subscriptions. We're going to improve performance of durable storage. We are adding integration with Snowflake and Confluence schema registry. And we are adding client info-based authentication, meaning you can check, for example, if you use mutual TLS, you can check, build and check that, for example, CN of certificate is the same as username that the client connects with. And here's a link to roadmap, as usual. Yep. And the next slide. So our team in Stockholm attended Open Source Summit in Europe, and that was in Vienna, Austria. It was really intense 3 days. We had a lot of companies, a lot of people, and we had a lot of interesting conversation with our users, existing customers, potential customers, and other vendors who are doing something similar to us. Meaning, so we have an open source product, and we also try to make money somehow. So we have a dual license for our code base. Code is open for both open source type of community edition and enterprise, but for enterprise edition, some application can have dual license. They have business source license as well. And we've talked about like what other people do. It was very interesting experience. Yeah, I think that's it from me.
Okay. I think we're now heading to the Q&A session. Thank you so much, Brandon and Ivan, for your presentation. Are we seeing, I see one question, a few questions here from the Q&A tab.
Yeah, I did see one come in too. So thank you for your contributions. The window's not closed, so if you still do have thoughts or topics, either about, you know, the concept of manufacturing and IoT and unified namespace, please do pose those questions now as we go through these. And we will try our best to answer these. And for whatever reason, if we can't, just know that we will get back to you. And that we do have a library of information for every one of these topics, right? So happy to share those with you online. And so the first question I had here was, one of the problems is, I'll summarize it, had to do with buy-in, right? That was one of the challenges that was not on that slide, and they're wondering how you can go about kind of getting through that and getting that time to value, right? So it's a good question, one that we hear quite a bit in the field there. And what I can say there is go ahead and start small, right? It's going to be an uphill battle to try and just deploy your entire worksite oftentimes, right? More often than not, for leadership, it's going to require, small POC or a targeted line or area to be able to prove the concept. And then once you're able to get that done and kind of grab that low hanging fruit, you should be able to quickly speak to the value and ramp that up throughout your business. So it definitely is an iterative process, right? We don't know everything going into it. So that's why, time, money, investment, it's really good to go about the implementation that way. Thank you for that question. And I hope that answers your question. Another one was, how does MQTT enhance communication between various sensors, data systems, and smart manufacturing applications? So that kind of goes back to the concept of, leveraging something like a Neuron EX, which is deployed. And maybe, Ivan, if you have more thoughts on this after the fact, please do tag it on here. But being able to put that at the edge, and sorry, I'm getting some ghosting there, deploying it at the edge. And again, it's not our hardware, but we do recommend doing it on something as simple as a Raspberry Pi, right? We're constantly having conversations with other hardware vendors too, to kind of build out that catalog for options, right? But you can go ahead and deploy that, and you can put a broker on a Neuron EX instance as well. And the whole value there is you really want to hand over some of that processing power to the edge. So you can go ahead and process, ingest that data, and try and do the exchange to just learn in the cloud. So that's another way, mechanism to kind of cut out costs in operation there. But again, Neuron plays a huge part there. It also has its own onboard rules engine, as well as in the EMQX broker. So there's a lot of mechanisms in place for logic to be able to unify those different protocols. As I mentioned, 100 plus earlier, and that's that's not the ceiling either. Yes, there's going to be protocols that we don't support that are more kind of one-offs, right? But given if the case is strong enough, we can go ahead and talk to the team. We're very iterative, and we listen to our audience and pull in kind of what you guys are saying, right? So that is something that that in itself is a good solution on how you unify these different device types and get that value there. And the last thing, without going too deep in the weeds here, to help you through the rules engine part that I mentioned, for those of you that are familiar with Node-RED, we also have our own version of that in our solution called Flow Designer. So you do have the ability, you don't need to know, SQL language. You can go ahead and do a drag and drop interface to plug in these different rules to these different backend systems. Yeah, I hope that answers your question.
We have a few more questions coming in.
Yep.
Ivan, Jin, feel free to chime in.
Just to make sure, have you answered the keep alive one?
Oh, no,
Sure.
not yet.
No, I don't have any specific guidelines for setting keep alive timings. It depends on case by case. I would say some experimenting is required. Just maybe like a too small keep alive may drain the energy, I suppose. And too large keep alive may lead to larger dropouts.
Sorry, Ivan,
Yeah.
can you read out a question and maybe
you
open up
say
your
simple.
video? Yeah.
Okay, yeah, sure. So the keep alive question. Keep alive was mentioned. We are trying to find a good combination of keep alive time and when you have a cellular data connection to the edge device that seems to drop out at times. Do you have any guidelines for setting keep alive timings? I unfortunately don't have anything off the top of my head to say here other than try different values, see how it works in your environment. And the next question, UNS. How we can design a UNS with a guarantee with no data loss in all process from pick the data in PLC until storing the DB for X years. What is UNS? Universal namespace.
Yep.
Right. But how does universal? I'm not sure what universal namespace design has to do with data durability. It's more like about how you set up data processing. I think if you capture data that you want and save it to database, or maybe I'm missing something.
Yeah, no, I think that's a point that we harped on earlier, right? About it's why it's every instance of UNS is going to be different, right? There's a lot of different variables. Not even if folks have the same devices in play, right? Not everyone's going to want the same data points per se, right? So, how do you identify what's important for you, and how do you ensure nothing's lost, right? So, a lot of these devices are already firing and producing data today, and they're already being collected, right? So, I think if you're trying to talking about the transition from the system you have today into the stack, that's why it's a careful dance, and we, would do, like I said, it's an iterative process that oftentimes would result in start with a POC or kind of a consultation to kind of visit your site in some form or another, see what things are in play, and be able to together architect that in a way where there's kind of redundancies so you don't lose information, right? But that's, I think, the tactic and approach that would help kind of navigate that concern. And again,
maybe you can take the next one as well about industrial environment.
Yeah, so so the next one is my experience of using MQTT is in remote environments with small low power devices using SIM cards. In an industrial environment where there is a lot of noise, do devices use SIM cards or do they have to connect to internet, etc.? So intranet is one of the ways to do it, right? There's a lot of flexibility to be able to do these connections, right? So yes, if you can do wired, you can do wireless, you can deploy, as I mentioned, Neuron gateways in multiple areas. It doesn't need to just be one for your entire work site. And that'll help cut through the noise. It makes it more local to certain lines or areas. You can also deploy multiple clusters throughout your instance and site, right? So That's one way to kind of detangle that connection web, if you will, is doing multi-instance deployments, and that helps smooth things out a bit, right? And SIMs doing cellular is one means. There's a lot of different ways to skin a cat here, right? We would just need to identify what that best path is for you. But yes, whether it's Ethernet, any other industrial protocols that are communicating on site. You can even do on-prem, as I mentioned, if that's something that's of interest to you. Those are all just different high-level angles in which you can get around that high congestion, and also coupling that with the nature of MQTT, right? Even though there's a lot of connections, there's not as many concurrent flying data points, right? In some instances, you still will have to, right? But given the decoupling nature, you're only sending by exception, which I would recommend to be able to cut down on that overhead cost. So those are all things that would help kind of navigate that. And happy to share more information on that with you too, to take a deeper look, whether it's by documentation, which we have a whole collection of library, or written materials like white papers and blogs.
Yeah, I can take next too. Does EMQ has support in South America? It depends on what you mean by support. If you have an enterprise contract with us or use our cloud, we do provide support in America's time zone, both north and south. But if you mean like more like personal involvement, that someone could come to you, then I don't think that's possible. But we do have a person in Brazil. Like if you're in Brazil, like you can talk your native language if you need if you have some kind of issue.
Great. One thing I want to just tack on there too was, and Ivan already touched on it, right? I didn't mention that during the session. So with regard to cloud infrastructures, we support all of the leading ones, right? So AWS, GCP, and Azure. So a lot of the regions will be supported through kind of availability there. And if for whatever reason there's a region that's not supported, we can have a conversation, and there's a big enough case we can go ahead and weave that in to meet your needs as well, right? So there is flexibility on all fronts there. Just want to add that little detail.
Yeah, thank you.
Of course.
Next question. In our solution, MQTT ping between broker and client is happening in the background periodically and using resources. Is it advisable to slow the frequency or possibly disable the MQTT ping? I think it's a follow-up on the keep alive, and I think it's certainly not necessary. If you use TCP, you can just rely on TCP keep alive built in and try to tune that one. It's certainly enough to keep the connection alive. So to answer the question, yeah, it's you can try to disable MQTT ping and just see if you have TCP keep alive working. Next one, I'm not sure. Maybe Brendan.
Is it possible to send MQTT data through LoRaWAN? I don't actually have the firm answer on that. I'm happy to chase that for you. If it's specific to EMQX, no, I don't think today that we have support for this. Broadly, can the standard support that? I think the answer is yes. But again, don't 100% know. It's a good question, but we will fetch the answer for you on that, and we'll get back to you as soon as we can. Thank you, Oscar. And then what I want to do too, I saw the next question there. Saw the poll pop up.
I can take the last one right now. Can you give a brief explanation of the difference between QS1 and 2, its impact to bandwidth, and examples of why QS2 would be a good fit? I think I can give a simple answer. QS2 is useful if you want exactly once delivery on subscribers. Basically, broker will do the duplication for you. And it certainly has an impact on bandwidth. You have an extra round trip, like 2 or maybe more packet exchanges to ensure that the duplication is working. And some other impact is I think you cannot use shared subscribers with QS2, or it's more tricky because of the duplication factor. Hope that answered the questions. So if you don't need exactly once, if you can deal with sometimes same message being redelivered, QS1 should be just good enough in most cases.
I dropped a link in there too. I think it just went to us, so we'll have to pull that out. But as I mentioned, we do have a wealth of information on all these topics. So Ivan gave a great overview. Thank you, Ivan. If you want a really deeper kind of view with diagrams and spelled out for you, there is a link there too that we'll share with you. Great. Well, I think that was all the questions we had so far. If anyone else has any other thoughts, please do let us know. In the meantime, Keen, did you want to introduce the poll there that you pulled up? Oh, you're on mute.
Yeah, sure. I actually just launched the poll to gather your feedback on this session. It'll help us kind of know how to feel about the session and improve in our future sessions. So yeah, it'll help us greatly if you can take a few seconds and fill that out. It's a short poll, fairly easy. And if you have other questions, feel free to submit that in our Q&A tab. And that's mostly our Q&A session. And we mentioned that EMQX is available both for enterprise and cloud services. So you can always try our EMQX dedicated cloud services with the link below. We offer free trials, and we can always talk with you on different technicalities and different scenarios that you're facing. And as always, the best way to contact us if you have any technical questions or any marketing or sales questions, it's via our contact us link that's on the screen. That way we can know what's your specific needs and what exactly that you're looking for, and it'll help us to pin down the exact team and experts that helps you to get your project going and get your data sorted. That's mostly it for our session today. Thank you so much. Yeah.
Yeah, thanks everybody. And the last thing I wanted to share there too, thank you, Keen, was there are a lot of ways to connect with us, even beyond the contact us forums and such. So we are very active in Discord and Slack. We also have a newsletter on our website. So if you want to be apprised of the latest and greatest, we do send those out pretty often as well. So do blogs like a machine. So please do check out those channels as a source of information. And we thank you all again. Really appreciate it.
Yeah. We'll also send out a kind of wrap up email after the session in the next few days. So if you ever want to connect with us through all of our social media channels and Slack, Discord channels, reach out to us. We'll send all of these informations to you and get connected right away. Okay,
Great.
I think that was all for today's session. Thank you again so much for everyone for making the time. Thank you, Brandon, Ivan, for giving the informative presentation. We'll see you all next time.
Likewise. Thank you, everybody. Thank you, Keen.
Yeah.
Thank you.
Thank you. Bye-bye.
Have a good one.
You too.